It is massive. It just rose over the southeastern limb. It's the most likely place, in my opinion, for major solar flares. This and much more on today's Daily Space Weather. And welcome, everybody. We've got a massive uptick here in solar activity. We're going to have a sunspot number over 150. So to all you folks out there hoping we'd have 0 sunspots for an entire solar cycle, so you'd be right. Sorry. Here's a colorized magnetogram. And look at all the magnetic organization, especially in the southern hemisphere. We'll show you some crazy close-ups of this. Some additional crazy close-ups of it. Here's 94 and 131 angstroms, the two best frequencies to view solar flares from the SDO. It takes 10 images per minute at these frequencies instead of only 2 at the rest. And here's a full disk view in ionized helium, 304 angstroms. There were some coronal mass ejections. We'll cover it in a moment. None of the most recent have been Earth-facing. So there was one on the 20th. We'll get to that as well. That's expected to arrive late in the day tomorrow. The radio flux now up to 137 solar flux units. And there's the one-year chart. The black line here is the radio flux. You can see way up, approaching 140 solar flux units. And again, this red line here is going to reach 150 or more today when it all gets compiled. So here's the Space Weather Enthusiast dashboard, and you can see late in the day tomorrow, early on Christmas Eve, we're expecting the onset of a coronal mass ejection strike. NOAA forecasting this only to be producing a geomagnetic unrest period of about 15 hours. So late in the day tomorrow and early in the day on Christmas Eve, we're expecting to get a little bit of geomagnetic unrest, according to NOAA. Largest quake of the past 24 was an American quake once again here on Alaska. So give us a shout out if you felt that quake. People like Brett, our longtime viewer, located in Anchorage. That was a 5.9 magnitude earthquake there. Pretty significant, and it was at depth also, 152 kilometers. That would be like a 6.5 magnitude if that happened at the surface. We'll scroll up the rest of the list here. Continued activity off the coast of Petrolia, California. Otherwise fairly quiet as far as earthquakes go. Volcanoes have seen an uptick. We'll get to it next. And if we fail to report anything here on the earthquakes section, just leave us a comment. We consider these videos a collaborative effort. Thanks to everybody who contributes. Please share the videos with your friends and foes. And that 5.9 came in late in the day. 22:42 Universal Time is when that one occurred. Hawaii continuing to see quakes even though the Halema-Uma'u Lake has actually stopped filling. South Sandwich Islands also saw a 5.9. That's the most seismically active portion of the whole planet. Quite a few quakes in the U.S., also a 4.9 at Iceland. And let's continue on to volcanoes. Again, we see a little uptick in volcanoes here the past week or so. Sakurajima producing an 8,000-foot ash plume. Subanose-jima, 7,000-foot ash plume. Mount Manam, now back on the list. 35,000-foot ash plume. Flight level 350 over Papua New Guinea from Mount Manam. So Kilauea has apparently stopped filling its Halema-Uma'u lava lake. Nope, that's not a Star Wars thing. That's the real name of it. Halema-Uma'u, part of the Kilauea magma system. The lava flow ceased from the Western Fissure vent, but a glow is still visible. Hunga Tonga, Hunga Ha'apai, still erupting in spectacular fashion, producing a 40,000-foot plume of volcanic ash. Also a pumice raft showing up southwest of the volcano. Also strong degassing continues. So a violent eruption happening there on Tonga. Great Sitkin continues an effusive eruption. So new real estate being created there at the Great Sitkin volcano in the Aleutian Islands. Fuego, exploding 15,000-foot ash plume over Guatemala. Sangay, 20,000-foot ash plume from Sangay over Ecuador. Revenador has dispersed its volcanic emissions. Sabancaya intermittent emissions over Peru from Sabancaya. And Piton de la Fournaise on the Isle of Réunion detected a seismic crisis, and 3 eruptive fissures opened. That's on the southern flank of Piton de la Fournaise. New lava flows have emerged, so more real estate being created there, also on the Isle of Réunion. A great reminder, do not pole vault the caldera. Today's featured product is the Do Not Pole Vault the Caldera socks. Smash Staff and I own them. They're quite comfy. So pick up some public service messages here for your friends and foes. Remind them to not pole vault the caldera. With the state of affairs of human knowledge nowadays, it may be wise to tell folks that it may be unwise to pole vault the caldera. Let them know. You can find links to this and more below the video. So pick up some merch. It's pretty sweet. It's got our YouTube URL on there and so on. Support the channel via some hot merch. Don't enter a hot lava lake as a result of attempts to pole vault the caldera. You can also support the channel via the Smash team. We've put up a massive number of posts. Here's a sneak peek. And to see any more, you'll have to head to the website, smashamash.com/Smash team. That's our daily disaster report. It usually only goes out to gold and silver level, but through the holidays, we're welcoming everybody to the Neo-Renaissance for free, thanks to our Smash team members who help to keep the site and the content in existence. Again, links at the homepage as well as below the video to smashamash.com and to smashamash.com/Smash team. And the next thing we'll talk about here at the Smash News Network, least busted name in news, is the magnetic environment. Let's do it. Here's the GOES magnetometers over the past 3 days. Nothing too exciting happening there. There is a continued coronal hole wind stream arriving. We'll get to that in a moment. First, the current sheet. And we expect Earth to be in a North Pole current sheet by the time we make tomorrow's daily space weather video. You can see this North Pole current sheet over here. Here's a South Pole current sheet shown in red. North Pole shown in green. And there's one speeding this way as we forecasted as a result of activity in the southern hemisphere. Or at least correlated with it. It's a chicken or egg physics argument. Next, the line of sight ecliptic plane field plot. And yeah, North Pole current sheet headed this way. Massive activity rising in the southeast. Could be the largest sunspot of the cycle so far, and it is beta gamma class. So here's the line of sight coronal hole plot showing the sun's B field in these blue potential field surface source lines. And you can see 2 transequatorial coronal hole systems here. One North Pole oriented one here farther to the east, and a South Pole oriented one farther to the west, shown in red. As solar cycle 25's solar polar field reversal process suddenly kicks into overdrive. So here is the the best wavelength probably to view coronal holes, 193 angstroms. 211 also works well. And there is an M-class solar flare or 2 in here, and they're becoming routine at this point with the number of sunspots we have. Don't worry, folks, the sun's not going to kill you. Great view of this little M-class flare and associated plasma behavior. Let's get to even more. Likelihood of major flares is very high. We reached all the way up to 13 named sunspot groups there, as you can see on the list here. 2916, once again, is the most likely place, in my opinion, for major flares. We've been seeing a series of M-class flares out of some portion of all of this magnetic complexity over here in the southwest. And here are close-ups of sunspot 2916's rising. Again, it's beta gamma class and more than capable of producing major flares. Spectacular imagery there from the SDO intensitygram. So you can see there was another M-class flare here. Peak flux of that was at 7 o'clock this morning, so 7 a.m. Universal Time there. There was another M-class flare accompanied by a radio blackout over the Indian Ocean. And if you want to follow the attenuation of the ionosphere, here's where you do it. The de-region absorption predictions referring to the lower D level of the ionosphere, which gets attenuated during solar flares. And it causes radio signals to pass through instead of being refracted, redirected, whatever you want to call it. Radio blackouts, expect lots more with the number of massive sunspots we have. So there's that one that was centered over the Indian Ocean. And of course, wherever it is at noontime is the spot on the world where you can expect to see the biggest radio blackouts from solar flares. No spikes in the proton flux. No relativistic particles have showed up at all as a result of all these flares. Don't be surprised to see some. And if you do see some, you can expect to see like week-long disruptions in polar ionosphere. You'll see lengthy absorption regions happening when we see relativistic particles showing up, but we don't see any at the moment. Next, we'll head to the real-time solar wind. And we see some likely errors here. This is a little bit too flatlined to be believable, and you can see the error bars lit up here down at the bottom, all those yellow portions. Those are likely errors, and we're seeing errors coming in at the moment. Let's head back to the moment when the errors were less likely. So we're still seeing an elevated solar wind here, approaching 600 kilometers per second. So the coronal hole wind stream continues. Solar wind density showing up there near the end of the run at about 14.5 protons per cubic centimeter. So a bit of a density there, as well as a significant speed. The BTBZ recently shifted as well. The BZ is now in negative territory, but the total field not that strong at the moment. An indication there's still lots of plasma out there as it streams this way. So here's the KP index, a measurement of global geomagnetism over the past 3 days, and you can see KP of 2, geomagnetic calm conditions. Geospace magnetosphere movies are still down. We've got massive GPS errors. We'll get to that momentarily. And I would remind you once again to not be frightened of planets. Here at the Smash News Network, least busted name in news, we don't really want you to be frightened, period. Although, the idea that you can avoid fear entirely is an infantile and ridiculous idea. Fear can save your life, so don't expect to have none. Here's a diagram of the solar system. We'll show you a 1-week forecast. There's where things will be in a week. As far as the moon goes, we'll have a crescent waning as we approach another new moon. Next, a star chart. This is what's going on above my head at the moment. The sun is just about to cross the galactic plane, as you can see there based on the yellow line and the blue line. That's what's going on over the Lehigh Valley. If you want to put in your location, head to in-the-sky.org. If you want a chart like mine, pick the All Sky Charts. Lots of interesting data there at in-the-sky.org. And the moon is just about to set here over the Lehigh Valley. Let's take a look at Lagrange point 5, as we did see some coronal mass ejections. The most recent not Earth-facing, but stereo A's data is back online, so let's check it out. I would note the timestamps. We do have different timestamps here. So on the left, we've got the stereo A raw imagery. There is a coronal mass ejection there. That's likely to miss the Earth to the south. And for you new viewers, Earth would be out in this direction from the stereo A coronagraph. Just to bring it back to the diagram here, stereo A is located here at Lagrange point 5, the gravitational equilibrium point where it follows the Earth as it orbits the sun in this direction. It's called stereo A because it views space weather ahead of Earth, because it rises in the east. Anyway, we've got the difference imagery on the right. That's more recent, and this imagery on the left is more old to show you that coronal mass ejection. And there's actually one still unfolding at the moment, so it all looks like it's about to miss Earth to the south. We're not even going to show the LASCO C2 and C3 on this video. We'll make another video today if necessary. regarding cosmology segments, we've got hundreds of them at the Smash News Network, least busted name in news. So check them out via the playlists at youtube.com/smashamash/playlists. And let's get to a cosmology segment. It'll be brief and integrated today, not separate. First, the astronomy picture of the day. It's a SpaceX Falcon, I believe it is. It's time-lapse imagery of a rocket launch from Florida. It is a SpaceX Falcon 9, which was carrying the Imaging X-ray Polarimetry Explorer. If you want to read more about that, you can find links there as well at apod.nasa.gov. The astronomy picture of the day. If you want to read more about the Imaging X-ray Polarimetry Explorer, again, there are links at apod.nasa.gov to that. Using polarized light to give us additional insight into what's going on in cosmic objects. Things like pulsars and magnetars and Centaurus A. The polarization of the light gives us data that we could not otherwise get. It has to be imaged from space. And we're stoked about the imaging, the IXPE, the Imaging X-ray Polarimetry Explorer. Today's random object is number 780, which is a pulsar, magnetar, and interesting gamma ray source located on the galactic plane in the Milky Way galaxy. Here's the most interesting spot. It's a dip in the X-ray flux to the point where it wasn't sending any. It was sending no X-rays back around 2018. And here's a 30-day chart. You can see it's actually recently shut off. So it's a cyclic object here, SGR 1806-20. And here it is in X-ray. This is on the Chandra X-ray telescope. Now this is a gamma ray source, and it's surrounded by other very bright gamma ray sources. We're not going to worry about that. Actually, let's bring up a gamma ray image. So here's a great image. This is the greater than 1 tera electron volt electron flux, gamma ray flux rather. You can see what a significant gamma ray source that is, although there's some even brighter ones around it. It's a pretty violent object. Let's take a look at some more wavelengths. And here it is back to X-ray frequency. This is the XMM Newton. Great X-ray image there. And this does show up in some tight spectral bands. So we can see some tight spectral bands there, the portion of the electromagnetic spectrum in which this is visible. And let's zoom in and see what we can see in optical bands. Here's the Pan-STARRS bands Z and G. Looking pretty dark at that pulsar, magnetar, gamma ray source. And how about on the 2MASS? Here it is in infrared light. And you can see quite a lot of thermal spectra around there. Probably some major filamentary activity happening, and some relativistic particles certainly, to produce the kind of gamma rays that it does indeed produce. Here's one more image from the XMM Newton in optical. You can see again it's a pretty dark location there on the galactic plane. And when we bring it back to X-ray frequency, and that is at the same zoom level, a completely different signal. So once again, that's the Chandra X-ray imagery of today's random object, SGR 1806-20, a gamma ray source located on the galactic plane. It's entry number 780 at the Neil Gehrels Swift-Bat X-ray Observatory. If you want to read more on that, go check it out there. There are all kinds of links. That's today's cosmology segment. We hope you enjoyed it. And we hope that you have checked out the other cosmology segments on our playlists at youtube.com/smashamash/playlists. Next, we're looking at charging hazards. We don't see any at the moment, although we do see massive chaos in the electron flux. So we're expecting an electron storm as well here. You can see the levels are now back up above the moderate levels. That's a one-year chart of the relativistic electrons surrounding planet Earth. We did briefly make it into warning levels yesterday. And the forecast is for an increase in the electron flux. So we'll have to see what happens with this one, as there are various different things happening, like a coronal hole wind stream, as well as the arrival of a CME tomorrow. So here's the forecast, and you can see a big uptick expected here in the electron flux. I wouldn't tend to argue with that. That's the NOAA forecast. The green boxes, the yellow diamonds, are not lucky charms. Those are the observations. Next, the total electron content forecast, and it's quite chaotic. Expect massive GPS errors, especially around the equator at noon. And here it is. We'll let this play through twice, as it is quite significant indeed. So massive GPS errors over the Pacific Ocean, subsiding a bit over the Indian Ocean, but major GPS errors also over North America. And this is when you want to have your Wi-Fi accuracy turned on for your location services, because you could be off by thousands of miles and your GPS is not going to be able to give you directions if it's off by thousands of miles. Total electron content forecast is interesting in the past week. Next, we're going to show you the ionosphere. Feel free to pause the video here if you want to read more about electromagnetic penetration and chemical concentrations and temperatures. Here's the F layer located at about 300 kilometers of altitude, and significant anomalies in the ionosphere continuing here. I would note down here, attract your attention to the Drake Passage, one of the weirdest places in the world, where the Atlantic and Pacific Ocean attempt to reach static equilibrium. Imagine how much water has to flow through that narrow channel in order to do that. What happens when you have a high pressure over here and a low pressure over here? How much water gets shoved across the Drake Passage? Anyway, just putting it out there. And we'll bring up the latest image. We'll also show the anomalygram. So here's the anomalygram, anomaly in megahertz from the 30-day median. Significant anomalies and some pretty large swings in the ionosphere, giving us insight into what's going on with the electron flux and Earth's magnetic field and so on. Electrons are only about 1/1800th the mass of a proton. And so they tend to move as a result of magnetic field shifts. Anyway, so here's the latest image. That's 1400 universal time. We are seeing some anomalies once again. And there is the anomalygram, ionogram, showing vibrational frequency, an anomalygram showing anomaly in vibrational frequency from the 30-day median. Mostly high-frequency anomalies happening at the moment, such as this one over the Caribbean. And let's do bonus features. All right, so there is your GFS forecast for positive snow depth change through Christmas. So this isn't referencing snow that you've already got. This is just an 84-hour forecast based on the GFS model for positive snow depth change. So 80 hours is pushing it. It's beyond 3 days, but it's pretty close. You may see some tweaks happening to this. That's the current GFS model. Here's the GFS model for positive snow depth change over the U.S. And quite a bit of snow continuing to fall here. Another 3 feet forecasted there for parts of California. More like 4 feet for portions of this southern part of the range here. We're certainly seeing 4 feet of snow showing up on the model there. That's the 84-hour positive snow depth GFS forecast for the lower 48. Likelihood of a white Christmas here in Lehigh Valley, Pennsylvania, kind of low at the moment. Here's the European forecast for the lower 48. That is through 2200 on Christmas. Not expecting a white Christmas on either the GFS nor the Euro model. And for Eastern California, yowzers. Buried in foot after foot after foot of snow. Next, your weather.gov map. If your county is lit up, just click it at weather.gov. We can't go over all those counties. There are a lot of counties in the U.S. And most of the warnings here are winter weather related. Anyway, once again, weather.gov. Here's your NASA GOES lightning map, or no terrestrial lightning over the U.S. And here's a real-time lightning map, I think. And we did originally stream this video live, folks, so just bear with me. There we go. And we've got bonus features built into the daily space weather. Make sure you watch our meteorology segments. And we brought daily space weather, people, just for a quick moment during the recap. If you don't watch the meteorology segments, there's part of it. And the first bonus feature is Cerro Tololo's ground-based solar observatory located in Cerro Tololo, Chile. We've got a solar flare and a coronal mass ejection warning in place. Look at all the filaments down here. All kinds of stuff going on. Coronal holes, sunspots. This massive sunspot group, 2916, is the most likely spot to see a major flare, in my opinion. Let's see what's been going on in the past few hours. This is the NASA GOES 16 SUVI imagery. Check out this filament up here. Pretty sweet. Again, we've got all kinds of stuff coming out. Lots of posts at smashomash.com/smashteam. Check it out. Become a member over there. Again, lots of free posts throughout the year 21, the old year. So check out this sunspot. It is quite significant. And all of these are capable of producing significant flares, folks. Many have. We're at the point where C-class flaring is the background level. Again, we're going to have over 150 sunspots today. And if that was a smooth monthly value, that would be a higher value than Solar Cycle 25's solar maximum. Here are the magnetic fields. Again, quite complex. Beta-class sunspots galore. I've lost track. We made it up to 13 different named groups, as you saw in the Integrated Space Weather Analysis Center video. Crazy amounts of activity. So here we are with a full disk view in 171 angstroms, my favorite wavelength. And here's a composite with the 10 image per minute 94 and 131 angstroms wavelengths from the SDO. We'll be keeping an eye on it, and when I say ion, pardon the pun. In any case, we'll be back with some more content coming soon. May that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name and news.